In the next 3 videos, I'm going to talk about incorporating qualitative predictor variables into a multiple linear regression model. And to motivate this, I'm going to think of an example where we're trying to figure out how much individuals are getting paid at a particular company. So I've got some information here on salaries in thousands of dollars, and I've also got the genders of these 4 individuals. And the question is there any suggestion of gender discrimination here with regard to salaries? And so we could look at this and note that the 2 males are getting paid a lot more than the 2 females, and so we might wonder, well, is there something going on here in terms of gender discrimination? Well, we probably need to collect some more information, so let's look at the job titles that these 4 individuals have. So it turns out that the 2 males are managers and the 2 females are clerical workers. So is it the case that the 2 males are getting paid more because they're managers and not because they're male? Well, how could we go about determining whether that was the case or not? Well, we would need information on male clerical workers and female managers to determine that. So let's suppose we have another 4 employees, and we've got 2 female managers and 2 male clerical workers. So now let's look at the clerical workers. The 2 females are getting 20 and 30. The 2 males are getting 25 and 40. So the male clerical workers are getting paid more than the female clerical workers on average. Let's look at the managers. The 2 female managers are getting 35 and 50, and the 2 male managers are getting 45 and 60. So again, on average, the male managers are getting paid more than the female managers. So maybe there is gender discrimination here. Or maybe it's to do with work experience. If we look at the female clerical workers that were getting paid less than the male clerical workers, they've also got less experience on average. And if we look at the female managers who are getting paid less than the male managers, they've also got less experience. So perhaps it's not gender that's driving salary differences here, it's experience along with the job title. So if we could determine what the salary formula is at this company, and if the salary formula is based solely on job title and experience and not on gender, I think we'll have shown that at least based on the limited information we have, there's no suggestion of gender discrimination here. So how are we going to do that? Well, we can do that if we can code the information in the qualitative predictor job title using numbers. And in particular, if we can define something called an indicator variable or a dummy variable, then we can code that information in numbers in a way that the computer can understand what's going on. So in particular, if someone is a clerical worker, they're going to be coded as D equal to 0. Whereas a worker who's a manager is going to be coded as D equals 1. And then how does this work? Okay, it turns out that the salary formula at this company is given by this equation. Salary is equal to 15 plus experience plus 15 times D. So what does that mean? Well, that means, for example, let's think about a clerical worker with 5 years of experience. Okay, a clerical worker has a value of D equal to 0. Okay, so if we plug in D equal to 0 and experience equal 5 into this formula, then we get 15 plus 5 plus 15 times 0, which comes to 20. Let's check if that's the case. So here's at the top, this is a clerical worker with 5 years of experience, and sure enough their salary is $20,000. Okay, so the salary formula works for the first individual. What about a manager with 5 years of experience? So a manager has D equal to 1. So if we plug in D equal to 1 and experience equals 5 into this formula, we can calculate their salary. So it's going to be 15 plus 5 plus 15 times 1, which comes to 35. So a manager with 5 years of experience gets a salary of $35,000. Let's see. That's this individual here. Manager with 5 years of experience, $35,000. Okay. Turns out that if you use this formula for all of these employees, you get their salaries. And note that this formula has nothing to do with gender. So what we've demonstrated here is that for this set of 8 employees, there's no suggestion of gender discrimination here, because we can create a salary formula that does not have gender in it. Okay, let's look at a slightly different example. So here's some similar salary data. Okay, again, I've got 8 workers. 4 of them are clerical workers, 4 of them are managers. We've got their salaries here, and I'm also using this indicator variable D that's going to have the value 0 for clerical workers and 1 for managers. And I've also got this other variable here, experience, that we're going to use in our model. Okay, so I'm going to switch to R now, and so here's my data. Okay, so I've got salary, I've got experience, I've got the job titles, and then I've coded the information in job titles using my indicator variable D. Okay, and let's look at a picture of the data. So I'm going to plot my points. Okay, and so here's my 8 workers. I've got experience on the horizontal axis, salary on the vertical axis, and I've marked my points according to whether they're managers, which are the M's, or clerical workers, which are the C's. And now I'm going to fit a multiple linear regression model with experience as one predictor and this new indicator variable D as my second predictor. Okay, and we're going to see what happens. Okay, so I get my estimated coefficients here, and I'm going to focus on these numbers. So 15 for the intercept, 1 for the regression parameter that multiplies experience, and 15 for the regression parameter that multiplies D. Okay, so what does all that mean? Okay, so here's my equation, 15 plus 1 times experience plus 15 times D. So for clerical workers, D equals 0. So if I plug in D equals 0 into this formula, this piece will go away and I'll be left with 15 plus 1 times experience. What about when D equals 1 for managers? Okay, if this is equal to 1, I'm going to have 15 plus 1 times experience plus 15 times 1. And if I simplify that, I'm going to have 30 plus 1 times experience. Okay, so when I'm using the indicator variable D to code information on whether someone's a manager or a clerical worker, then I get an equation for clerical workers that's equal to 15 plus 1 times experience, and an equation for managers that's equal to 30 plus 1 times experience. Okay, so I kind of skipped over something here. How did I decide which job title was going to have D equals 0 and which job title was going to have d equals 1. I didn't really say, I just kind of stated that as a fact. So this decision is called deciding which level is going to be the reference level or the reference category. Okay, it turns out it doesn't actually matter. For all intents and purposes, it doesn't really matter, and we'll see that in a second. But we need some kind of rule of thumb to use here. So often what will happen is either the most common category will be the reference category, or there'll be some meaningful baseline category. So here we might argue that, okay, well, people when they first come to the company, they're going to start off as a clerical worker, and maybe they're going to get promoted to be a manager. So let's have clerical workers be the baseline and managers take on the value 1. Okay, what if we decided this the other way around though? What if we'd coded this the other way so that managers were 0 and clerical workers were 1? Okay, would that change our model? Okay, so let's actually do that. So if I define d star now, so d star now is going to be 1 for clerical workers and 0 for managers. Okay, and I'll fit this model 2 as the model with experience and d star instead of d. And now I get an intercept of 30. Okay, let's go down here. An intercept of 30 and a regression parameter for experience of 1 and a regression parameter for d star of -15. Okay, note that everything else is the same. So I want you to note that all this information down here, regression standard error 1.21, r squared 0.9942, this f statistic down here 425.8, these are all exactly the same as they were before. Okay, the other number that's the same as before is the regression parameter for experience, 1 here and 1 here. The numbers that changed were the intercept, changed from 15 to 30, and then the regression parameter for the indicator variable changed from 15 for d to -15 for d star. So what does all this mean? Okay, so well, let's work through the calculations we worked with before when we used d instead of d star. So here's my regression equation, 30 plus 1 times experience minus 15 times d star. What does that equation simplify to when d star equals 0? In other words, managers. Okay, so I'd have 30 plus 1 times experience minus 15 times 0. So this piece will go away, and I'd be left with 30 plus 1 times experience. And for clerical workers, d star equals 1. So if I have 1 here, I'm going to have 30 plus 1 times experience minus 15 times 1. I'm going to have 15 plus 1 times experience. So when we use d star, I have two equations. The manager equation is 30 plus 1 times experience. The clerical equation is 15 plus 1 times experience. When I used d, I've got two equations. I've got a clerical equation that's 15 plus 1 times experience, and a manager equation that is 30 plus 1 times experience. In other words, I get the exact same equations, regardless of whether I use d or d star. Okay, so that's what I mean up here by it doesn't really matter which level is the reference level, as long as you've made a note of what is your reference level, because it's obviously important which one is the reference level. But when you do these calculations here, you'll end up with the same two equations. Okay, so that's an introduction to using indicator variables to model qualitative predictors in multiple linear regression. And there's a few things going on here, and the most important thing is here. When you're setting up your indicator variable, in this example we've got two different categories. We've got clerical and manager, and we've got one indicator variable that enables us to come up with two equations, and there'll be one for clerical workers and one for managers. The two values of the indicator variable are 0 and 1, and so you pick 0 for one category, which will be known as the reference category, and then the other category will be the value 1. And then when we get our regression equation, we can plug in the value 0 and simplify the resulting equation to get the value for one category, and then we can plug in d equals 1 and simplify the resulting equation to get the fitted equation for the other category. Okay, so there's a lot to talk about with indicator variables and using categorical predictors, and so there's going to be 2 more videos in this little sequence. The next one I'll talk a little bit more about examples where we have 2 levels for my qualitative predictors, and then the third video in this little sequence will talk about an example where we have more than 2 levels in a qualitative predictor.